Viewers, welcome to another episode of Dialogues from our platform. Today, I have the privilege of having with me Lieutenant Dr. Anill Kapoor to talk on a very important subject about how the autonomous weapon systems are changing the manner in which we fight wars and how the technologies are impacting the development of these. Of course, you can learn more about General Anill Kapoor by going to his LinkedIn profile. The link to that is in the show notes below. So, General Kapoor, first and foremost, so many technological advancements are taking place and they are being used to develop a variety of autonomous weapon systems. The whole very dynamic of battles, the battlefield, the conditions are changing. So, what is your overall view on these changes which are happening? General Kapoor, please.
Firstly, thank you very much. It's been a long time that we engaged on this forum. It's indeed a very interesting subject on autonomous systems. I think over the last, if I may say, decade or so, given the speed at which technology is advanced, autonomous systems have somehow garnered the maximum interest both in the defense and in the commercial space. In the commercial space, let me say first, the digital transformation has resulted in automation, and the next step beyond automation is automation to autonomy. And today we have a lot of industries engaging beyond Industry 4.0 and graduating from industrial automation to industrial autonomy. Now, that is one end of the spectrum. Also in defense, what we observe is that it's becoming manned, unmanned system teams. And unmanned space over a period of time is actually ruling the goose, in the sense that I think man-unmanned fight is a very unequal fight. You are fighting machines. A human being is fighting machines. And therefore, I think looking at the overall perspective, the tech landscape has actually facilitated major changes. Now, the first thing that comes to my mind is the ICT convergence. I mean, earlier we used to have a radio set or a communication device and a computer. And ICT convergence has actually given so much of power to a device, and today our mobile phones and the way we are speaking, the whole system has got fused into this kind of converged system. So this is the first thing, that convergence is actually making a lot of difference. Part of this convergence is nanotechnology, which has brought in a lot of miniaturization, that the function, form, and fit has actually been condensed so much that today you are able to create a product or a device which actually carries out a lot of functions which otherwise required a major form or a major fit. Today, it requires, because of miniaturization, it doesn't require all that. The third is the material science has undergone a major change. And while we already talked about nanomaterials, I think in this space, rare earths and other such materials, which actually have not earlier been, if I may say, employed so much in applications, today these are being employed on a massive scale. And we looked at, very large scale integrated circuits. Today, nobody talks about them. Today, in view of miniaturization, you talk of MEMS, you talk of semiconductor, you talk of semiconductor device, you talk of IoTs, you talk of various sensors that are getting facilitated, and in a very small product, you have a variety of sensors. So that is one very big change. The next is creation of data. Because of these sensors, humongous amount of data is getting generated, and because of which big data analytics has become a very vibrant field. And the last and the most important is artificial intelligence. A human mind would not be able to pick up so much of data and make sense out of it. And therefore, mathematical algorithms, machine learning and deep learning models, neural networks have come in so that you're able to pick up all this big data and start making sense out of it in terms of analytics, more importantly, in terms of decision support. So really speaking, the human mind today, along with technology, has created a synthetic intelligence, which we call artificial intelligence. And even artificial intelligence has grown with time and continues to grow. We all heard of algorithmic AI in our younger days, where we used mathematical models. Then we got into data analytics and AI based on data. And now today you have got generative pre-trained transformers, the GPTs, and chat GPT is a very good open AI source. Then you got explainable AI. So there are, today AI is actually the mainstay which is helping in creation of software-based decision support or information-based decision support, which actually is transcending from automation to autonomy. So today, you and me can depend on a product to be autonomous. We can depend on a drone to be autonomous in its operations. We can look at unmanned ground systems. We can look at driverless cars. We can look at anything where man can be out of the loop, and wherever required, we can introduce man in the loop. So really, that is the autonomous space that we are looking at today.
Yes, indeed. In fact, you have just brought out so many things like the semiconductors which are needed for it, the sensors which are needed for it. Then you brought out the importance of data. You brought out the fact that artificial intelligence is coming in a big way. So, in your view, what is it nations have to do so that they are able to get the ability to create these systems effectively for their own use, both I would say in the battlefield and also in peacetime? Anil, please.
Super, sir. So how I look at this issue is that I think it's a great strategic thought. Firstly, to think that we will be embracing autonomy. So that's a big decision first. And we look at creating an ecosystem for design, development, and deployment of autonomous systems. Now, when we say design of an autonomous system, we need to define some very clear objectives. Where do we want to do it? Do we want to have industries which are autonomous? Do we want to have our road space traffic management which will be autonomous? And do we want our healthcare to be autonomous? Now, just as an example, the digital public infrastructure that we created has actually created so much of autonomy within the digital space that today in India, right from metros to the edge, which is a village, actually we are digitally connected. If you see from a digital lens, there is no difference between sitting in Delhi and sitting in the remotest of the village in any part of the country. Today, even a vendor, street vendor, enjoys the power of autonomy through digital infrastructure. The moment you do is QR code is sure that the money is got transferred into his bank. So that is the power of autonomy. So really the first step is to define some very clear objectives and go in for a purpose-driven design. Now, whether it is defense or it is commercial space today, again, there's a lot of convergence here, because when you look at a digital space, it is agnostic of the data. If you give it military data, it will give you military decision support. If you give it industrial data, it will give you industrial decision support. If you give it healthcare data, it will give you healthcare decision support. So basically the platform that you create or on this can actually have what we call multi-platform, multi-sensor data fusion to be able to give you what you need based on your very discrete requirements. So the first thing is define a purpose-driven design, and then look at various stakeholders uh, who actually will facilitate this. Now, if I look back at our Aadhaar card system, how it developed, I think it tells you a very good story that just one Aadhaar card, you know, along with a PAN card, two of them have created a huge financial visibility in the environment. Today, every of our financial documentation is governed by PAN, and moment you link Aadhaar with PAN, you have full-scale visibility on your complete financial bandwidths. So similarly, I think we can create a lot of bandwidths in so doing. And let me now from here get to the military space. When we look at defense, sir, today you can actually let me first talk of soldier readiness and then talk of equipment readiness. Now, you and me who are veterans today, if at every point in time our data was digitized or a digital footprint of our service record was there, and how we handle crisis, how we manage crisis was recorded through some sensors which exist today, based on your body language, based on your face language, or your facial expression, on the way you manage stress. I think nobody needs to generate a report on you. Every day, there would be a balance sheet of what your contributions to the system are, what is your tolerance for ambiguity, and any other aspect of leadership which you exude would actually be very well captured in the digital space. Now, that said, doesn't mean that you throw the man out of the loop, but it only tells you that a lot of relevant inputs for a 360-degree appraisal can be made available on the soldier readiness. Now, just one very discrete example. Let me take firing standards as an example. We all go for firing very, very regularly, and it all gets documented on the day when there's a test. Similarly, our battle proficiencies, similarly, our skills that we acquire in our profession. Now, if there's a way of data capture regularly, you do physical training daily, you do your weapon training very regularly, you do your skill development very regularly, and if it was a digital footprint of whatever you achieve every day was encapsulated, at the end of a calendar year, you could get, or one could get, a very clear view of the soldier readiness of each soldier based on this good data capture. Now, similarly, your medical reports and a lot of historical data would actually get tagged in. So if I got posted with under your leadership, if I came to you, actually a lot of historical data would be available to you, which otherwise you don't have, to know what Anill Kapoor was and what Anill Kapoor is. So really, a lot of historical data can be collected to see whether my soldier readiness is on an upward trend, on a downward trend, or plateaued out. Because there's a huge amount of historical institutional memory which goes in a digital space. So really, when we look at from an autonomy perspective, a digital record actually tells you a lot of story about your soldier readiness, your true soldier readiness, looking at trends, because trends are very important. Now, if we were to look at from a equipment perspective and defense, now imagine if you put, today we've got cars with close to 150 ECUs with almost 1,000 sensors. Imagine if we were to look at our legacy equipment or our contemporary equipment which we have, with this kind of a data available, you actually would get a historical perspective of each piece of equipment, how it is behaving. A very unique history of each equipment, a unique history of types of equipment, something that we've all been talking about, and trying to maintain a record manually actually gets automatically recorded. And how a equipment behavior is changing, and I'm using the word deliberately, behavior means the failure patterns, how are they emerging, how a particular maintenance activity is being carried out, what is the response to a particular mechanic, what to an equipment. A lot of these issues which today remain unknown would actually get adequately addressed. More importantly, condition-based monitoring, something that we have discussed on this forum earlier, would actually give commanders at all levels and maintenance agencies at all levels the shape of things to come based on residual life. Now, the third pillar I would like to touch here is the operational pillar. Now, we have a lot of attempts being made at information decision support system. We've been talking of integrated theater commands. We've been talking of integrated operations, joint warfare, and so many such issues. I think unless we have a common data dictionary, a common data repository, and a platform where all three services come together on their information front, which is geo-referenced, then and only then we get true value of a decision support system. As an example, if you know in real time, say in any operational area, what is the forward line of own troops, and this gets truthfully translated to all the army echelons of decision making and the Air Force echelons of decision making in a joint environment. In real time, you could actually reduce a lot of fratricide. More importantly, you can make some very cogent decision making to see where you are and what is the intensity or the capability of threat that you face as you advance in an offensive operation. Just to take one example. And similarly, we could get into CICT, we can get into so many operations to see how an autonomous operation bandwidths actually impact every aspect of soldier, of the equipment, and military operations, including decision making and decision support.
Yes, indeed. You have covered a huge canvas. And if you recollect, some time back, we had talked about academia industry linkages. And that's what my next thought is coming in my mind is that, especially I know that you are very much involved with the education system. You are closely working with one of the IITs. So, what you have said is actually, what is your opinion about how easily or how difficult it is to achieve it within the country? And could you throw some light on, in your mind, what are the sort of projects maybe educational institutions could take to do at least some sort of a creation of technology which can do what you have just explained? Because some new technology will have to be developed, or the current available technology will have to be reshaped. So, what is your response to that? That how can the academia maybe start contributing towards developing of such systems, which you have just painted a picture of? Please.
Right. Now, looking at the whole gamut of activities, actually, it all starts with a technology strategy. I think that's a yawning gap. While there is a lot of energy in the country, given the clarion call for Atmanirbhar Bharat, Make in India, Gati Shakti, Digital India, Skill India. But I feel if we have to really make some tangible progress, and we have this Ayushman Research Foundation also, which is actually looking at a lot of funding. But what is perhaps the missing link to my mind is a very cogent technology strategy. Now, but leaving that aside, if we do have a technology strategy in mind with autonomy as the focus, now we could look at a large swath of areas of governance, areas of national development, all of which will need a support of tech for autonomy. And actually, I'm today in IIT Tirupati and I'm going to take a talk on precision agriculture, autonomy in precision agriculture, and maybe I can, throw some light which will have huge amount of relevance everywhere. Now, if you look at agriculture ecosystem, and why I picked up agriculture is, technology and agriculture appear to be two very distant friends, but I think they are very close buddies. And it all starts, and most of us understand this as well, it all starts with two very important things: the quality of soil and the quality of seed. So if I'm a farmer, firstly, and I'm growing wheat, I should be able to discern a good quality seed from a mediocre quality seed. Now, an experienced farmer would be able to perhaps do it with relative ease, but for greenhorn farmers, you will need technology to be able to discern, which is a good, which is a better seed based on so many inputs, both by destructive tests and non-destructive tests. So that is the start of. So I'm just saying, if we break the whole process, we'll see that on the one side, so I'm calling it a project seed, where and then identify tech that is required, whether it is in terms of lidar, whether it is in terms of optoelectronics, whether it is in terms of chemical tests, all that gets into the technology landscape to be able to identify the best seeds. And then we look at project soil, where we see if I have to grow wheat, what is the ideal to be state? And I find out what is the real time is as a state. And the gap between as is and to be has to again be filled before I sow that seed for optimum performance. And therefore, I think the next important thing is the tech required to create, to identify firstly the as is state, the to be would definitely be known. So, how do you assess the as is state? Again, there are electronic sensors, and why I'm harping on lidar every time is because that's a very, very important sensor in the field of soil analysis, amongst others, which could be used. And therefore, that is the other tech that needs to be done. And all of them have to be done when we come to now soil, it has to be done based on georeferencing of ground. So the next important tech is the georeferencing of everything, to be able to identify in a piece of land which is the one which requires maximum support and which is the one which is almost readily available. The third is weather. And therefore, in project weather, you have to see what is the optimum weather condition which will be to sow. And therefore, that's one very important input that would be required. And again, tech plays a major role. Today, we got Doppler radars, we got weather radars, which actually are playing a major role. And recently, there was an exercise done by ICRISAT along with Microsoft, and they put just these three things together: the seed, the soil, and the weather, and in one sowing season, improved the yield by 30%. Now, and I can go on, but the point is, which I'm trying to highlight is that there is definitely a need to come up with projects on one end and technologies required on the other end. And as nations, as we move forward, now when we look at, say, missions, semiconductor or mission quantum, I think there is a big, big message. Both these are futuristic enablers for autonomy. And why do I say so? Today, the whole communication is shifting from human to human, human to machine, into machine to machine communication. And when we have M2M communication happening at the speed of light, you can imagine the amount of data transfer that happens. And therefore, bandwidths become very important. Semiconductors to create sensors becomes very important. And most importantly, what is important is processing, and that is where quantum technology comes in. So if I were to break mission quantum into a program quantum, I would say we could have projects on one side, that is, quantum computers could be a project, quantum computing could be a technology, handling qubits of different types. If we look at quantum radars, quantum radar could be a project side, and on the technology side, we could look at synthetic quantum materials, which actually would enable radar signatures. And therefore, we need to create verticals on project verticals on one side and systems vertical or technology verticals on the other side to create technologies. And a very good example, of course, is our integrated guided missile development program, where right from 1984, and we've just gone beyond 2024, the program still continues to deliver. And if you look at this structure, it had projects on one side, technologies on the other. And today, technology is on the gallop. The beauty is that the guided missile development program looks at all levels of TRL. So on the project front, they look at futuristic projects, uh, uh, Agni 5000 and beyond. They look at BrahMos Plus of various kinds. And on the technology front, we continue looking at TRL 1 to 3, which is purely with academia since we started there. Now, today we are doing a large number of projects which are next 5 years on various type of materials, looking at TRL 1 to 3 with academia. And a number of projects are on this, including on sensors, sensor tech of future. We're looking at neuromorphic sensors, which are the next gen sensors, which actually replicate the retina of the eye of rods and cones. And this is going to be a big game changer, not only in space tech, where it is required, but also in huge amount of vehicle technologies when we're looking at driverless cars, because we're going to build it. And similarly, if we look at iron domes of the future, neuromorphic sensors will be very, very important. So that's a great research which is happening in the domain of TRL 1 to 3 today. And then that's a pure academic research at this point in time. And then you graduate to TRL 4 to 6, where you have academia industry interface. So you look at a development agency, you look at a production agency, and you take it to various applications and some products that can be made in the domain of TRL 4 to 6, so that you create some prototypes. And having done that, then the industry takes on from TRL 7 to 9 and then converts it into deployable products. So really, when you look at the design, development, deployment cycle, design is largely TRL 1 to 3. Development is TRL 4 to 6, and deployment is TRL 7 to 9. So that is how the whole gamut of academia, industry, government interface actually would pan out.
Thank you very much, Anil. You have actually not only given out what is possible, and you have also given out what are very clearly the methodologies which we can follow to reach that. And viewers, with that, we come to an end to this particular episode of Dialogue, and we look forward to bringing more such episodes to you. Jai Hind.